was a close one. Look where I'm at. I broke in, guys. Don't say anything. It's technically not called breaking and entering if you work here, right? Alright, 6th grade. I am sitting at my desk. I never thought I would be so happy to be sitting here. The only thing that would make this better is if you guys were here. Anyways, you guys started learning about Sir Isaac Newton yesterday, and Sir Isaac Newton was more than just a scientist. He was a mathematician, he was an inventor, he was a great deal of things. He didn't let things keep him from trying to work harder, and he was pretty cool in how he contributed to what we use still today. So we're going to start going through his 3 laws, and today we're going to focus on his first law of motion. And I'm going to give some examples as we go through this lesson, and I hope you enjoy it. So here we go. Newton's first law of motion. Sometimes we call it the law of inertia, and it basically states that an object at rest will stay at rest, and an object in motion will stay in motion unless it's acted upon by an unbalanced force. So let's talk about that for a second. Let's pause for a second and just talk about that. If something is just sitting there, it's going to stay there. It's not going to move. It's not going to magically get up and float away. The computer, the tablet that you're watching this on, as long as it stays in one spot, it's going to stay there. It's going to stay at rest. But as soon as you apply an unbalanced force, meaning, who remembers the definition for force? That's right, it's a push or a pull. You're going to get that object to start going in motion. And an object is going to stay in motion unless it's acted upon by an unbalanced force. So something will stay in motion until a force is acted upon them. Now, we've talked about a couple of forces that could inhibit or cause motion not to work. Can you think of those things? We'll get to those in a second. So an object traveling in a straight line at a constant speed tends to keep moving that way. So here would be an example. We have this soccer ball that's at rest, and it's going to stay at rest sitting on the grass unless acted upon by an unbalanced force. Well, what is the unbalanced force in this picture? That's right, we have the foot coming through, swinging through to come hit the ball, and that object now is in motion, and it's going to continue in motion with a constant speed and direction unless it's acted upon by an unbalanced force, which in this case is the net that is stopping it. Let's look at this example. We have a motorcycle that was in motion, moving at a constant speed in a straight line, and this object would stay in motion until an outside force acted upon that, and this would be the tires. Now, we're talking about this object right here, this unfortunate soul right here. He was riding this motorcycle. The motorcycle got stopped, and he kept flying. Now, he is now an object in motion that will stay in motion until an outside force or an unbalanced force acts upon it. What is ultimately going to bring this cyclist back to the ground? That's right, gravity is going to pull him back down, and then we also have what that will stop him from sliding across the ground? Friction, that's correct. Let's go to the next slide. So this term inertia, let's talk about what that means. The resistance to a change in motion is called inertia. So we're going to skip this part about the car because we haven't done that yet. But let's look at this example of inertia, and then I'll show you a different one. Inertia, basically, your truck has brakes. This massive hunk of stone does not. So this truck is in motion. He's driving along, has a lot of momentum going for him because he is weighed down with a lot of, stone. And the truck hit the brakes, but the stone inside of it wanted to keep moving because it was resisting that urge to stop. So let's go back to what I said we hadn't talked about yet, the car. Let's talk about when you're sitting in a car and I don't know, which parent is the crazy driver? I'm going to say it's me and my family. I'm driving down the road with my family, and we're moving. I, as a person sitting in that car, am moving along with the car, but I don't have the ability to stop I don't have the ability to keep moving. It's the car that's doing that. So I'm just going along for the ride. And I am not paying attention, and all of a sudden I see that the cars in front of me have stopped, and I need to hit the brakes. So when I slam on the brakes, I'm driving along, I slam on the brakes, the car's stopping, but my body wants to keep going, and it's going to cause me to go forward. That's why we wear seatbelts. Or, you guys ever been on the roller coaster rides in Orlando that shoot you off really fast? Your body is sitting there, it's at rest, it wants to stay at rest, but then the car that you're sitting in, the roller coaster car that you're sitting in, all of a sudden takes off super fast, right? Your body, you feel yourself being pushed to the back of the roller coaster seat because your body is trying to stay at rest. Inertia is saying that it wants to stay at rest. It's trying to resist starting to move. So, inertia is something that where an object wants to resist either moving or beginning to move, or your body is resisting the ability to stop moving. So let's go through some examples now. When we have swings, when you go to push someone on a swing, it's harder to get that person started than it is to keep that person going. I first have to overcome the tendency for that body to stay at rest, right? So let's say that I was, there we go, now you can see that whole thing. Let's say that I was trying to push someone and it was a really heavy person. That person is going to, it's going to be a lot harder for me to get that person swinging than it would be for me to keep them going, correct? Let's look at some more examples. We've talked about velocity in the past. We know that velocity not only involves speed, how fast something's going, but also in a certain direction. I know that a lot of you go to the fair, and if you've ever been on a ride that spins around, you know that your body wants to go straight even though the ride turns. So think about this. Whenever you've been on one of these rides that spins, normally which person needs to sit on the outside? Usually the bigger of the two. If you've ever been the unfortunate one to sit on the outside and you're the smaller of the two, you know that you're going to get squished by whoever's on the inside. So if my body wants to keep going in a straight line, it means that when someone is spinning me, or I'm being spun by a ride or by swings like this, I'm trying to keep moving in that straight line even though it's turning. This is why when you go on swings like this, you start to swing out to the side because you're trying to go in that straight line. If you've ever swung an object on the end of a rope around and around, when you release the rope, the object goes in a straight line from the point that you let it go. It doesn't continue circling. So this idea that something wants to keep moving in a straight line, perfect example is if you go outside and I don't know, if you have a younger sibling, don't do this because you're going to get in trouble. But if you have a younger sibling and you grab them by the hands and you start twirling them around and their feet are going up in the air and they're laughing and having a good time, and then you turn into the mean sibling and you just let go. They don't keep spinning around in a circle because they don't, gravity's not going to let them and inertia's not going to let them. They go flying in a straight line until what forces act upon them and bring them back down to earth. That's right, gravity and then friction causes them to stop spinning. Don't do that, but if you did, that'd be kind of funny. But don't. So we know that objects in the universe do not remain still. They keep moving in straight lines. Now, if I was to jump up to shoot a basketball, I will not continue floating up in the air, unfortunately and fortunately. If I was to roll a toy car across the carpet, it's going to roll for a while, but then it'll come to a stop because certain forces are acting upon it. stopped. So what force caused those two things to stop rolling? What caused that basketball to fall back into my hands? So one force that keeps an object from moving indefinitely or forever and ever in a straight line we know is gravity. That's the pull of one object on another. Now objects that with greater mass have a stronger gravitational pull. Since the Earth has more mass than anything on it, it pulls objects towards itself. This is why we have the moon revolving around the Earth, because the moon's mass is less than Earth's mass, and the Earth revolving around the sun because the Earth's mass is less than the sun's mass. Now, when it comes to gravitational pull, we are pulling, like us walking on this Earth, we are pulling the Earth towards us just as much as the Earth is pulling us towards it. But because it has a greater mass, it will always win. So if I was to throw a softball through the air, gravity is going to pull that ball to the Earth, and at the same time, the ball is going to pull the Earth towards itself. But again, the Earth's mass is so much greater than that of the softball. So the pull of the ball to the Earth is very, very tiny. You get it now? All right. The second thing that's working against inertia is friction. And this can be helpful in many ways, or it can be harmful in many ways. Without the force of friction, we wouldn't be able to walk across the floor. Our foot would not be able to grip the floor and push us forward. So friction would be on the ground. You ever walk in slippery shoes? It's disaster, especially if you're in a crowd. As I step forward and push down, the friction here of the ground is allowing me to move forward. If you try to walk on ice, there's less friction. Therefore, it's very difficult to walk on ice. Same thing, like if I was to try and turn over in bed in the middle of the night while I'm sleeping, or stopping my car, those things would be impossible if we didn't have friction. You need to have brakes. And in order for brakes to work, there has to be friction. There are these little calipers here that squeeze these rotors that slows the car down. If we didn't have the friction there, you wouldn't be able to stop. Now, sometimes people like to increase the friction of a surface. How many of you have like the bottom of your bathtub, you have either like almost sandpaperish type stickers there, or some sort of friction mat that keeps us from falling. If you've ever fallen in the shower, ooh, I'm sorry. Baseball players, for all you baseball players, when you wear batting gloves, or even football players, when you wear gloves to catch the football, it keeps your hands from slipping either off the bat if you're playing baseball, or it makes them very sticky to catch the football. Also, rubber tires give more friction against the road and help keep bikes from sliding on the road, and you can see the difference in the friction of these tires based on what their purpose is. You obviously want to create a lot more friction on a trail because, well, there's dirt. Other situations, friction's not very helpful, and we try to reduce it. Winter sports, which we have a lot of here in South Florida. Winter sports like sledding, skiing, ice skating, these are only fun when there's less friction. The worst thing, if you've ever gone sledding, is to get on a sled that stops as soon as you get on it. You want to have less friction. So snow skiers and snowboarders, they'll use wax on the bottom of their skis to reduce the friction. It allows the skis to glide quickly along the snow. Skeleton racers, I actually did this for a while. Skeleton racers will adjust what's called the rock of their sled. These little blades down here, they'll adjust them by making less of it touch the ice. So if less of it is touching the ice, you're going to have less friction and you're going to go faster down the bobsled track. And engines. People will put grease and oil on